Hello, guys. Good evening, or maybe for someone of you, it's good morning. My name is Denis Dushyn. I am a software engineer working in DataArt. Last several years, I work mainly in financial field or web commerce. And today, I would like to share with you some information about Graal platform, or another name of this Graal virtual machine. It's a new technology that is based on OpenJDK. It is in the Java field. And today I would like to talk about one interesting feature that is available in this platform, and it is called multi-language or polyglot platform. So I think we can start and go to the next slide. First of all, I would like to say that there are two different editions for this platform. You can get it on official site. One edition is community. It's available for free and anyone can use it for any purpose. It's free for any use. The second edition that you can find on official site, it's an enterprise edition. It is free for evaluation purposes, but if you want to use it in production, you have to buy a license, and this enterprise edition provides some additional performance, security, and scalability features for applications that you can run in production. I would like to make a little introduction to this ecosystem, Graal virtual machine, because it's a big ecosystem. At the heart of this platform is Graal virtual machine. It is based on OpenJDK. That's why all applications that you can run on OpenJDK, it is possible to run on this platform. Also, Graal platform provides additional capabilities and features that allows to run applications written in different languages. First of all, it's ByteCode targeted languages such as Kotlin, Scala, or Java. And also it's possible to run programs written in other languages such as JavaScript, Ruby, R, or Python. Even in some cases and for some programs, it's possible to run programs written in C and C++. Also, Graal platform can be embedded into Node.js. Also, it can be a part of Oracle database. Also, the platform provides additional tools that allow to create standalone applications. It allows to write programs in languages that were mentioned before and compile them to native images that are available for your operating system. It may be executable images for Windows operating system or Linux or macOS. Also, Graal virtual machine and this platform provides one great framework. The name of this framework is Truffle, and it allows to create interpreters for different languages. For custom language, or for example, by default, it provides interpreters for JavaScript, Ruby, R, Python, and even interpreters for C++ programs. On this slide, I would like to summarize what I said before. At the core of platform is Graal virtual machine, and it is based on OpenJDK with one exception. C2 just-in-time compiler has been replaced by a new compiler, Graal. The main task of this just-in-time compiler is to create assembly machine code from the GVM bytecode. It is a building block for almost all other components of Graal virtual machine. The next big component or even feature, it's a Truffle framework. This is our today topic. The main feature of this framework is it provides building blocks for creation of interpreters for language. By default, Graal virtual machine provides interpreters for JavaScript, Ruby, R, Python. And the next big component is Substrate VM. It's a framework that allows to do ahead-of-time compilation of Java applications into executable native images. And the last one big component is Sulong. It's an interpreter for LLVM bytecode implemented with Truffle. It's one of the implementations, one of the interpreters that is implemented with help of Truffle framework. So it was an overview of Graal virtual machine. And today I want to talk about multi-language features that is available out of the box and provide some samples or examples how to use it. Some command line commands how to invoke or use available interpreters for other languages. First, I would like to start with one rhetorical question. Is one language enough for solving practical tasks? It's a rhetorical question, and we know that one language is not enough because some languages are low level and is appropriate for programming CPUs. Other languages is high level and provide some or implement some programming idioms or stick to these programming idioms or concepts, for example, like procedural or functional programming. Some languages are designed for solving some particular tasks. For example, R is a good fit for statistics. Another example of languages is Python. It is good for DevOps tasks, but at the moment, it's a good fit for data science pipelines or implementation of neural networks. We know also that one language is good for front-end development, where on backend, we usually use another bunch of languages that is specific for server-side processing and provides more capabilities and features. What is the current state of this language ecosystem? There are a lot of different hardware platforms and operating systems. Windows, macOS, Unix-based distributions. As we know, in Unix world, there are a lot of different Linux distributions, Debian, Ubuntu, Fedora, and other ones. For example, for some languages, there is one platform like GVM targeted languages, Scala, Groovy, Clojure, Java, or Kotlin. Other languages have its own runtime. And in the era of microservices architecture, it is a common pattern to develop applications in different languages other than Java. It's possible to use JavaScript, Python, Ruby, Haskell, or other kind. On the other hand, in order to develop and provide a good performance and stability for languages runtime, developers spend a lot of time in supporting these runtimes for each language, and it's a difficult task. Also, development of new language is a big and difficult task. So GraalVM, Graal virtual machine, tries to answer the questions and try to provide some services for language implementers and to provide some runtime that can be used by language implementers and programs and on this slide, the main idea that has taken in the development of Graal virtual machine is to provide some runtime platform with basic services like memory management or thread management, and to provide these capabilities and these features to other languages. So for example, if I read a program in Java, I know how to configure a virtual machine, its runtime, then it would be possible for me to write the same application or additional application in JavaScript or another language like R or Ruby and run a program on the same platform. So the basic idea is to provide one runtime, but for different languages, and provide some kind of interoperability between these languages. In this case, there is no need in separate runtime. So on the next slides, I will show you how it was possible to do and what is the current state of this platform. First, let's look inside the Graal virtual machine. First of all, it is based on OpenJDK. It has two different builds. One is based on OpenJDK version 8. The second build is based on OpenJDK 11 version. And the main difference in Graal virtual machine is just-in-time compiler C2. It has been replaced by Graal. This is a new cutting-edge just-in-time compiler that is written in Java language. It is open sourced and is possible to look inside the implementation. It is production ready, and everything that is possible to do with the OpenJDK and C2 just-in-time compiler is possible to do with this new Graal just-in-time compiler. Also, this new JIT provides a new feature. It can understand special abstract syntax trees that is generated by Truffle framework. And this Truffle framework provides basic building blocks for writing interpreters for custom languages. So if there is some implementation of a language, JavaScript or Ruby or another one language like Fortran that is written with help of Truffle framework, it's possible to run that language on top of Graal virtual machine. So the main building block is its new Graal, and the second building block for languages, for another languages, or for that provides opportunity to run programs written in different languages. It's a Truffle framework. So these two building blocks provide basic capabilities and features in order to run applications. So it's a Graal just-in-time compiler that can create assembly code, install it in code cache inside the virtual machine. And the second one, it's a Truffle framework. It's, as I said before, it's a language implementation framework. And currently it provides Graal virtual machine or GraalVM has built-in interpreters written with help of this Truffle framework. On the next slides, I would like to introduce this framework, what is possible to do with this framework, and how it works inside. It will be an overview of framework, and afterwards I will leave links that you can use in order to gain more information about this framework. So let's start from the basic information. So what is Graal and Truffle? First of all, Truffle framework provides it's framework for building abstract syntax trees interpreters. So the main idea not to build a compiler for this, for some language, JavaScript or Fortran or Ruby, but to build abstract syntax tree interpreters. So the main idea is to parse program written in some language, build parse trees, and on top of parse trees, build abstract syntax trees, inside which language implementer specifies how to execute instructions. All this is possible to write with help of Java language, and Truffle framework will use this information, these abstract syntax interpreters, and will speak to Graal just-in-time compiler that can understand this abstract syntax trees generated by Truffle. Some optimizations will be applied in abstract syntax tree or by Graal just-in-time compiler, and JIT will provide performant code, and it will be done automatically, or as I written here, is automagically. So as a result, when we have these two building blocks, Graal just-in-time compiler and Truffle framework, it's possible to write just abstract syntax tree interpreter, and you will have automatically performant runtime for language. How it can be depicted with help of some images. Let's suggest that there is some program written in some language. The first step is to create a parser for this language, and as a result, there will be some parse tree. That parse tree can be translated into abstract syntax tree, and Truffle, with help of Graal, will translate this abstract syntax tree interpreter into JIT code that can be later installed into code cache and used by a virtual machine. And procedures that applied during transformations from ASC to JIT code is called partial evaluation. Partial evaluation, it's a technique that is used for several different types of program optimizations. And one of optimization is called specialization. Main idea of this technique that usually is used in writing compilers the main idea is to run the program, first of all, in the interpreter mode. So when there is abstract syntax tree, it's possible to interpret node by node all the operations or program, and during the execution in the interpreter mode, gather some profiling information or profile this execution, and after that, just specialize some parts of the program based on the profile information. And for example, if inside the program there is some operations that are more performant on strings, then use that information and provide specialized operations for strings or for numbers. And after application of specialization, pass this new interpreter into JIT and convert to assembly code. One example, in order to understand it more deeply. So let's take very, very simple example. When we have an operation or statement that calculates sum of two objects, left and right, and stores its information inside the sum variable. So the result of operation may depends on two variables, left and right, and it depends on its types. For simplicity, let's suggest or assume that left and right are natural numbers. Truffle framework uses is written in Java language, uses Java language, and it's possible to express addition operation as implementation with big numbers. it will provide accuracy, but it's not performant. If, for example, we know that values are between integer min value and integer max value, so all used values inside this range, then it's possible to use another operation that is part of GDK, it's math at exact statement. So when someone writes an interpreter for language, it's possible to specify that for some types, please use big numbers, and for other types, please use another operations math at exact. So this is a type of specialization operation. Just use information, and based on profiling during the execution of or during the interpretation of a program, choose one or another path and JIT that code and use it when appropriate. So let's convert these all data set into images. First of all, after pass operation, we will have abstract syntax tree. It is depicted as plus and with the X and Y, like instead of left and right. When in nodes plus specialization stage, it's possible to replace, for example, for integers with the specialized nodes. For other operations, fall back to default type using big integers. And then just recompile this abstract syntax tree. Graal and Truffle framework may periodically during the program execution find more and more useful information during profiling and do node specializations and recompilation. So it's not a static operation that only once Truffle and Graal JIT code. From time to time, it will be de-optimized because new information is available and new specializations may be applied. So these node specializations are specific for each language and usually specified by the language implementers. Truffle framework provides a lot of annotations and a lot of useful utilities that can with help of these utilities, it's possible to specify all the edge cases and also provide some generic cases in order how to translate these instructions of a language into abstract syntax tree, and that information later will be used by Graal in order to JIT that code, that AST. And Truffle framework will decide during the interpretation when to apply the specializations according to collected profile and also according to language semantic, because language semantic it's at language level it's possible to done all operations by the language implementers. So language semantics is also specified by language implementers. On this slide, I will summarize all that I said before. So optimizations will be applied on two different levels. First level, it's an abstract syntax tree level, where type or node specializations may be applied. In literature or compile theory, you can find another name. It's rewrite rules. Also, on AST level, there is another optimization that calls hot calls inlining. You may know that just-in-time compiler may do inlining of bytecode operations, inlining of methods. On AST level, it is called hot calls inlining, just another name with a little slight difference. After optimizations on AST level, just-in-time this tree will be passed to Graal, and Graal will translate this tree into assembly code. And on bytecode and assembly level, it's just-in-time compiler will apply its own optimizations. The most common and known is loop optimizations, dead code elimination, and all other optimizations that just-in-time compiler knows. And especially starting from version 9 and starting from Graal, just-in-time compiler, there is a new escape analysis that is called partial escape analysis. It is also automatically available. So if someone wants to write a language, it's just enough to implement parse and also create specialized trees that is called abstract syntax trees, mark some specializations, and run that program on top of Graal virtual machines. So summary is the following. Truffle framework, it's an open source library for building programming language implementations. It is available on GitHub. It's possible to tweak. It's possible to hack in if you want. Also, Truffle framework is built on top of Graal just-in-time compiler. Graal just-in-time compiler knows a lot of Truffle and knows how to work with Truffle-generated abstract syntax trees. By default, Graal virtual machines provides Truffle-based implementations for the following languages. So it's not only an experimental technology, but now it's a practical technology because it's possible to build interpreters, and Graal virtual machine provides interpreters for JavaScript, LLVM ByteCode, Python, and R language. So on the next slide, I would like to talk about how to run programs on GraalVM. First of all, what languages is possible to use? Out of the box, it's possible to use all programs written on languages that translated to bytecode. It's Java, Scala, Groovy, JRuby, JPython, Kotlin, and others, because Graal virtual machine is based on OpenJDK. Build procedures, build pipelines, and run procedures are the same. The second batch of languages that you can run, it's all languages that have a specific interpreter that is written with help of Truffle framework. By default, it's JavaScript, Python, LLVM ByteCode, R language, or if you wish, or for example, if there is some needs on projects, it's possible to hack into the Truffle framework and write parser for custom language with help of this framework and execute programs in a custom language on top of Graal virtual machine. So let's go to the practical part. First of all, you need Graal virtual machine. You can download it from the official site. As I said at the beginning of the presentation, there are two different editions. Community is enough. It contains all necessary interpreters. And out of the box, it's possible to run any program written in Scala, Kotlin, or any language that is translated into bytecode. It is available out of the box. So there is no changes in build pipelines because GraalVM is based on OpenJDK. Besides of that, Graal virtual machine provides faster compilation. It provides great efficiency due to a new partial escape analysis, especially it is critical for functional languages. It's possible to get some performance benefits just switching to a new platform. And also GraalVM provides possibility to convert applications to native images. If you have some microservices and would like to speed up the startup of the application, it's possible to translate Java bytecode to native images. The second language that it's possible to use and run applications is JavaScript. GraalVM includes ECMAScript compliant JavaScript engine. First option how to run programs written in JavaScript is to use JavaScript interpreter. It is based on Truffle framework. It is available out of the box. The second option is to use Node.js and APM. It is also available inside the GraalVM platform. The main difference is that it contains Java virtual machine instead of standard V8 engine. And GraalVM implementation of JavaScript interpreter is compliant with the ECMAScript specifications. Compatibility may be verified on the site. According to the documentation, compatibility level is the same as in Node.js. So almost all tests are passed, and it's possible to use without losing some semantics and functionality that is specific to JavaScript language. For other languages, we need to install specialized interpreters. In order to do that, you should install that interpreters with help of a specialized tool, Graal Updater. It is located inside the Graal. You should run that Graal Updater with the install command and specify component, where component can be one of the LLVM toolchain, Python, R, or Ruby. After completion of the install operations, you will have interpreters for these languages. First, what is LLVM runtime? As we know, some languages, it's possible to compile not to native language, but to intermediate language, LLVM ByteCode, and Graal Virtual Machine provides interpreter for this ByteCode. So after installations, this interpreter will be available, and also will be available as a lang compiler that can produce LLVM ByteCode. So if you have some program and want to write some program in C++ language, just translate into LLVM ByteCode and run that program. So like on this slide. And the last one is Python and R languages. At the moment, it provides only early stage implementation for Python language. Some of the operations may be not available for Python, but automatically you can run a lot of Python programs. The main purpose at the moment of the interpreter for Python is try to be compatible with the NumPy package and try to run applications that can be used for scientific computations. So the same is almost true for R programming language. It's possible to use R script interpreter and to run programs written on R language. And at the moment, I tried several different programs for statistics, and almost all I could run without any problems. So we are at the end of the presentation. So on the final slide, I am leaving links that you can use in order to find more information. First of all, I would like to leave first two links. It's a link to Wikipedia article about partial evaluation, what it is and how it can be used. The second link, it's a book. It's around 400 pages, but it describes a lot of optimizations that may be applied and how to use partial evaluation in theory and in practice. And also GraalVM provides a simple implementation or reference implementations for simple language that shows how you can write interpreter for a custom language and how you can implement language semantic with help of basic building blocks that are available in Truffle framework. So we are at the end, and now we can start question and answer section. Please, at this slide, you can see my contacts. You can write, if you have some questions, you can write an email. Just write email to me, or you can subscribe to my Telegram channel, where I sometimes share information about interesting technologies that is practical, usable, or just interesting for me. So, please give me several minutes. I would like to switch to YouTube chat. If you have questions, please ask in YouTube chat. So I see that there are no questions in chat. Thank you very much for time that you spent with me. And if you have any questions, just write an email to me and I will try to answer them and provide additional guidelines. So thank you very much, guys, and bye.